dilating a segment and giving the coordinates of its endpoint. All right, so for the last 2 weeks, we've been talking about transformations. And a transformation is just how we move or change a figure on the coordinate plane. So up until this point, all we've done is moved it around. So we've done translating. Translating is like if I take the pencil here and I just move it back and forth or up and down. Rotating it is literally if I turn it. Usually one point doesn't move. It's just turning on a point. And we've been practicing that at the origin. Or instead of just rotating it, there's also a reflection, which is flipping it. That's shown a little bit better with my hands here. So if I have my hands here and I want to reflect them, then I just pretend like there's a line right here and I flip it. And that's a reflection. So those are the 3 transformations that deal with just movement, not changing the actual figure. Dilating, we're actually going to change the figure. Not change its shape, we're going to change its size. So dilating has to do with making something larger or smaller. That's what we mean by dilating. So if we're dilating by a fraction is less than 1. That's why it's a fraction. So we're going to make a figure smaller. If we're dilating by a number larger than 1, then the figure is going to become bigger than itself, because 1 represents kind of like 100% if you think of it that way. So if the figure is getting more than 100% of itself, then it's going to get bigger. And if we're dilating it by a factor of just 1, well, if 100% is 1, then it means like we're dilating it to be exactly the same as it already is. So fraction smaller, 1 the same, anything bigger than 1 means that we're making it bigger. All right, so in this case, you can see this little slide bar here, and it tells us that for the figure below, do a dilation centered at the origin with a scale factor of 1/2. So they're already going to help you deal with the dilation centered at the origin. They're not going to make us deal with that part. The only thing they're going to have us do is change this little slide bar to be whatever this number is here. My printer's freaking out. So 1/2 means that we're going to slide this bar down to 1/2. And the 1/2 mark is just literally halfway between 0 and 1. Okay, maybe it'll stop making noise now. And then we have to give the endpoints of the original figure and the final figure. So you can see they give us space here to put in 4 different coordinates. We have 2 endpoints for the first one, 2 endpoints for the last one. So I wanted to show you, and then I'm going to get started because it's a little easier to actually show you how the slide bar works. So they literally just clicked it and they slid it over to 1/2. And you can see here's the original in gray and the new one's in blue. And it automatically shrank down a little bit. So that's what we're going to go ahead and. Okay, so for the figure below, do a dilation centered at the origin with a scale factor of 3. So 3 is larger than 1. We're going to make the image bigger. Okay, so just keep that in mind. This tells you if you're making it smaller or bigger. All right, so we're going to slide this bar over to 3, and that's it. That's all you have to do for this one, because it automatically dilates it for you. So over here, we have to make sure that we're paying attention to left and right. It will mark you wrong if you do it backwards. So for the original figure, we want the left dot first, or left endpoint first. So I'm going to go right 2, up 4. So right 2, up 4. Remember, the first number is right or left, second number is up or down. So it's just directions. I'm going to go right 4, and then I'm going to go up 4 for the second endpoint, or 4. All right. And then we're going to fill these in, and I want to talk about the relationship really quick, because there is a very easy relationship when it comes to dilation. All right, so we're going to go over to 6, and we're going to go up to 12. So 6, 12. And then we're going to go over to the right 12, and then up 12. So we have 12 and 12. All right. So if you notice the relationship, and you may have noticed as we were typing this in, so I have 2, 4. If I multiply by my scale factor, if I go 2 times 3, I get 6. If I do 4 times 3, I get 12. 4 times 3, I get 12. 4 times 3, I get 12. So that is the very simple relationship between the scale factor and the actual dilation or the new endpoints. You just multiply by the scale factor they give you. That's it. Super easy. All right, we got a point. Next. So we're going to, for the figure below, do a dilation centered at the origin with a scale factor of 2. So right away we can slide this over to 2. What that means is it's 2 times the size. So when we did 3 times the size, that's 3 times, or scale factor, that's 3 times the size. 4 times the size. 5 times the size. So if you notice that leaves the screen. So if they have us do that, we need to understand the relationship so that we can still fill in the endpoints. But in this case, we're just going to go to 2. All right, so we need to make sure we go left to right. So endpoint we're going to go right 2, up 4, right 2, up 4, and then we're going to go right to 6, and then up to 6. So 6, 6. So let's try that relationship I told you about on the last page. So if we multiply by our scale factor, we should have our endpoints. So 2 times 2 gives me 4. 4 times 2, that gets me 8. 6 times 2, that should get me 12 and 12. So let's make sure. Let's see, is this the endpoint for the left side of the new line? So we go over 4 and we go up 8. Look at that. Right 4, up 8. And then we're going to go right to 12 and then up 12. Check. Yay. All right, one more. So this next one, it says, for the figure below, do a dilation center to the origin with a scale factor of 1/4. So this is less than 1. So we're going to make the figure smaller. So when I had a scale factor of 2, that meant 2 times. The line was twice as big. When I had a scale factor of 3, that's 3 times as big. So if I have a scale factor of a fraction, I'm really just dividing by whatever's on the bottom of the fraction. So this one's going to be 1/4. And if you notice, there's 1, 2, 3, 4 spaces here. So I'm going to go down to 1 of those 4 spaces, 1/4. And there we go. That's a line that's a fourth the size of the original line. So now we're going to go over here to the endpoints of the original. We need left to right. So it's not a very easy line to see, but it's tilted just a little, so we have left to right. All right, so we're going to go over here to, yep, so that was right to 8, and then up to 16. So we have 8 and 16. And then we're going to go right to 12, but we're not going to go up or down. It's right on the line. So we have right to 12 and then 0. All right, so that relationship we were talking about on the last page still holds true. I can still multiply by this scale factor. And I know, for whatever reason, fractions do freak people out. But really it just means the number on top is multiplying, the number on the bottom is dividing. Multiplying by 1 never changes anything. So we want to just divide by what's on the bottom. So I'm going to take 8, and I'm going to divide by 4, and I get 2. And I'm going to take 16, and I'm going to divide by 4, because remember, we're dividing everything by this scale factor, and I'm going to get 4. Next one, if I divide 12 by 4, I get 3, and then 0 divided by anything is 0. As long as 0 is on the top, that's perfectly fine. So let's test that real quick. So for my first endpoint, I should get 2, 4. So I'm going to go over 2 and up to 4. Look at that. Right 2, up 4. And then I'm going to go right to 3, but I'm not going to go up or down. I'm going to stay on 3. Perfect. So it did work out. All righty. So we're all done with that one.